Okay, next up, polynomial operations. So what's a polynomial? An algebraic term that's the sum or difference of monomials, like 9x, 9x, 6xy, 0.5x to the fourth y, without division by a variable. So no negative exponents are present. An example of a polynomial would be x squared plus 7x minus 8. Okay, so the sum or difference of monomials. A monomial would be something like 9x, 9x, 6xy, 0.5x to the fourth y. So you see the sum or difference, addition or subtraction. All right, so how do we add or subtract polynomials? We add like terms, noting the exponents. So some of this should already be familiar. X plus 4x equals 5x. X squared plus 2x squared equals 3x squared. Now we're getting into actual polynomials. X squared plus 3x plus 4 plus x squared minus x plus 3. Keep in mind the like terms. That means they have the same degree or power of the variable. So we add x squared plus x squared, and that gives us 2x squared. We add 3x and minus x. That's the same as subtracting x, so that would be plus 2x. And we add 4 and 3. That gives us 7. So be sure to look at the exponents. You can't add the ones that are different exponents, unless you do some rigmarole to get around it, but we'll get to that later. Subtract like terms, same thing. 15x minus 5x equals 10x. X to the fifth plus 10x to the fifth equals 11x to the fifth. Okay, see how the powers are the same, the exponents are the same? So we'll do one 5x minus 4y minus 3x minus 2y. Same kind of thing, different variables. They can have different variables sometimes too, these polynomials. We're not going to see too many of them on the test, but let's go through this one. So you subtract the 5x minus the 3x, you get 2x. Subtract 4y from 2y from 4y, and you get 2y. So 2x minus 2y, and then you could factor that out, the 2, since there's a 2 in the x and a 2 in the y. You could take that out, put that on the outside, and do 2 times x minus y. Okay, it's important to simplify polynomials like that when you can. A lot of times that could be the difference between solving a problem and not solving the problem. So we look for those factors. Multiplying polynomials. We have the FOIL method for multiplication. That stands for front, outer, inner, last. And you look at the diagram down in the lower right. It's a diagram of that with A, B, C, and D. So when I say front, I mean term A times term C. Outer would be A times D. You see the second brown arrow? Inner would be the two inner polynomials, which is B and C. Last would be B and D. So let's look at x plus 2 times x plus 4. All right, the front, x times x, gives us x squared. X times 4 gives us 4x. 2 times x gives us 2x. And then 2 times 4, last, gives us 8. So we summarize the like terms. Okay, x squared, there's no other thing to the power of 2, but we have 4x and 2x. They're both to the same power, which is x to the 1. So that gives us 6x, and then plus 8. So it's x squared plus 6x plus 8. Again, this is the FOIL method. Front, outer, inner, last. You got to remember that. That's one of the few mnemonics you will have to really know for the test. The other's PEMDAS for please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction for the order of operations. Okay, let's factor some polynomials. Factoring polynomials is basically FOIL, remember the FOIL multiplication that we just did, in reverse. So you're going to look at the particular polynomial and figure, well, what would be multiplied against what to get that polynomial? A coefficient is the number in front of a variable. That's an important term. It's not on the exam, but it's helpful to know while we're doing this. So when we see ax squared plus bx plus c, the coefficient a is the number in front of that x squared, b is in front of the x, and c is the final constant. So you see what multiplies to the coefficient, the number in front of the variable, c, and adds to term b, and if applicable also a. So coefficient c is 8. 8's factors are 2 and 4. 2 plus 4 equals 6, which is coefficient b. A has no coefficient here. That's working back on the previous problem when I'm looking at that in terms of A, B, and C when we talk about those coefficients. The coefficient of x here is 1, the coefficient of B is 6, and C is 8. So you see we're working backwards with factoring on that previous problem. Okay, the next thing is dividing polynomials, long division. There isn't that much of this on the exam, but it is one of the topics, so theoretically you could get a question on this. So what you do is, let's say we divide 5x squared plus 3x minus 2 by x plus 1. You set up the problem. You start by dividing by the first term. So 5x squared, you divide x into that. Okay, and you get 5x. And then you multiply it. Okay, so 5x times x plus 1 equals 5x squared plus 5x. And you subtract. And then you get negative 2x. And then you bring down the next term, which is negative 2. And then negative 2x divided by x is negative 2. Then you multiply x plus 1 by negative 2 and subtract. This is kind of complicated, but I want you to review this. Please feel free to press the space bar if you want to pause it and look it over some more. It can be confusing. There's not much of it on the exam, but you should know it. It can be tested. Rational expression fractions. If they're the same denominator, you add or subtract. So 3 over x plus x plus 2, find a common denominator. We might multiply 3 over x by x plus 2 over x plus 2. Remember, that's equal to 1. Any number over itself is equal to 1. Multiply x over x plus 2 by x over x. And we come out with 3x plus 6 divided by x times x plus 2 plus x squared over x plus 2. You see the denominators are the same, x times x plus 2. And that's equal to x squared plus 3x plus 6 over x plus 2. And we could simplify that further, but I'm not going to bother right now. Okay, and that's it for this lesson. I'll see you in the next video.